Hello everyone and welcome back to the session. So till now we have completed all the data pre-processing steps required for this project, and from now we will start to build a model. So here we will be trying different machine learning models, and at the end we will finalize the model whichever is performing better. So let us begin. So first we will try with multiple linear regression model, for which we have to import this class from sklearn.linearModel import linear regression. So let us understand this linear regression class. So it's a linear model with quotients to minimize the residual sum of squares between observed targets and the targets that are predicted. So in simple words, we can say that this linear regression class tries to minimize the error between the predicted values and the actual one. So here we have to create an instance of this class, that is regressor underscore LR, which is equal to linear regression. And we are creating an instance of this class linear regression. And after that we have to train the model, the regression underscore LR dot fit, and in parentheses we have to give X train and Y train. So let us execute this command. So it's done. So here we have successfully trained our machine learning model. Now we have to do predictions on this. So for that we are defining y predict, which is a variable, which is equal to regressor underscore LR dot predict of X test. So now let us execute this. So yes, that's done. So now we have to analyze the performance of multiple linear regression, and to do that we will use R square, or we can say that the quotient of determination. So for that we have to import it from sklearn.matrix import R square underscore score. So let us execute this. So that's fine, it is done. So just for remembrance purpose, the best possible score is 1, or it can be a negative value. So this is R square underscore score of Y test and Y predicted data. So let us run this. That's good. So the value of R square is 0.7999. So as the possible score is 1, or it can be negative, so this is a good value. So this is all about our multiple regression. Let us move forward for the next model, that is the random forest model. So this is our random forest regression. Now here we have to look for ensemble methods. So let us import this one from sklearn.ensemble, then import random forest RF. So this random forest regressor works on a number of classifying decision trees. So let us train the model with the help of this class. So regressor underscore RF is equal to a random forest regressor, and after that we are training the model with X train and Y train data. So let us run this command. So now we have to do the predictions. So for that we are defining Y underscore pred, which is equal to regressor underscore RF dot predicted value of X test. Let us execute this. So it's done. Now we have to calculate the value of R squared, that is a quotient of determination. So which is 0.87759. As you can see, in multiple linear regression the R square value is 0.799, and here for random forest it is 0.877. So here we can say that random forest regression is working better than the multiple linear regression. So now let us try one more machine learning model, that is Boost Regression. So for that first we need to import this class That is from XGBoost import XGBRF regressor, and then we have to define the variable regressor underscore XGB, and then we have to fit the model with the training data. So now let us run this command. So here we have successfully trained our model using XGBoost regressor. Now we have to make the predictions. So redefine yPredict with the regressor underscore XGB dot predict. So yes, it's done. So now let us check for the value of R square in this XGBoost regression model. So which is 0.8826. So if you compare the values with the multiple linear regression and random forest regression, like for multiple linear regression it is 0.799, for random forest it is 0.877, and for XGBoost it is 0.8826, which means that out of these three, XGBoost regression is the best model as the value has increased. So we will finalize our model as XGBoost regression based on the value of R square. So let us revise what we have done in this session. So we have tried three machine learning regression models. The first one was multiple linear regression, then the random forest regression, and at the end we have tried with XGBoost regression. And here we have compared the performance of these three machine learning models on the basis of R square, that is the quotient of determination. And at the end we have finalized our model as XGBoost regression. So this is really about the building and finalizing of the model. So we'll continue in the next session.